Tonight's video will be focused on how weak acid equilibrium problem. So here's an example problem that we would be given on a test. Formic acid reacts with water according to the following equation. And notice that they give you the equation and they also give you the Ka value at a certain temperature. They ask us then to write the equilibrium constant expression, Ka, for that formic acid, and then to calculate the pH of the 0.15 molar aqueous solution of formic acid. Note that the Ka value is low, and therefore it is going to be a weak acid. The first thing I'm going to do is write the equilibrium constant expression for Ka for this weak acid of formic acid. Now, I was given this in the problem, which is the chemical equation, but I was also given this information on my equation sheet where it tells me the weak acid equilibrium, the formula is Ha goes to H plus A minus, and then it also gives me the acid dissociation constant of the expressions. So what I need to do is translate this equation into this. In order to do this, though, I have to understand that the concept that the H3O plus that is given to me in this problem up here in the chemical reaction is the same thing as the H plus that is given into the Ka equation. They're just a different way to write the exact same thing. So now all I have to do is basically plug and chug and match my things from my equation that I'm given to the equation that they give me on my formula sheet. And this is what I end up for the equilibrium constant for formic acid. So I have my H plus, which is translate from the H3O plus. I have my formate. Okay, and those are my two products that are the concentrations on top. And then I divide it by the concentration of my formic acid. Once again, note, I did not do anything with that H2O because it is a liquid and you do not put that in your equilibrium constant. Now I'm ready to solve for my second question, which is to calculate the pH of a 0.15 molar aqueous solution of formic acid. I know I'm going to need to utilize this later, so I just wrote it to the side here. Now I need to use the equation of pH equals the negative log of H plus, but I cannot utilize just this concentration right here. And the reason why I cannot do that is because it is not a strong acid, and not all of it dissociated to make my H plus concentration. Some of it still is formic acid, even at equilibrium. All right, so in order to do this though, I do need to figure out my H plus value. And so I'm going to need to solve, using my Ka, I'm going to need to solve for the H plus value in order to figure out what my pH is. Okay, so I'm going to need to use this ICE table. In order to do that, you are going to need to write your initial reaction going to your different products. Okay, and so initially what I want to do is I know that 0.15 molar of my aqueous solution of formic acid is what I started with. And so because this is the reactant, I am going to be producing, or I'm going to be starting with 0 amount of my products. So I will start with a 0 initial concentration of all of my products. Right? I understand that it is going to be decreasing because my reactants are going to be converting into my products, not all of them, but an X amount. So these guys will be decreasing as my formic acid at the same point that my products are going to be increasing. Okay, now it is also important to note that they are going to be increasing by the same amount. So I'm going to be decreasing by X at the same rate that I'm going to be increasing by X. And the reason why we're getting these is all of these coefficients are 1. Okay, so that's why it'd be 1X. Right? For this class, it's really going to be just minus X and plus X on both sides. So now in order to solve it, I'm just going to pretend this is my equilibrium at the end. And so I'm going to add these or subtract them together. And this is what I end up resulting. So my equilibrium concentration for my formic acid, for example, is 0.15 minus X. And I've increased my H plus by X and my formate by X. All right, now I'm ready to plug it into the equilibrium constant that I formed with my Ka, and this is the formula that I get by just plugging in my equilibrium numbers into this formula that I had already created. Okay, and so simplifying my X, I'm going to get X squared and then divided by 0.15 minus X. Now, for all cases and purposes, you could incorporate this X and solve for your Ka value of this. Right? You can, but that would incorporate using the quadratic equation. For most classes, for this class, entirely, and for most AP Chem classes even, this number of x is so insignificant compared to the 0.15, especially because your Ka is for a weak acid, which is really small. You can just ignore this x. You're not going to ignore the numerator's x, but you can ignore the change that was resulted by the by reaching equilibrium for your denominator. So in the end, you can just drop that x in the bottom, and you will end up with the equation of x squared over 0.15. And so now this is a simplified version. I've gotten rid of all the extra information, and so now I'm ready to solve for my x. So the first thing I'm going to need to do is I'm going to rearrange it, and then I'm going to take the square root of that. Now all I need to do is plug in my Ka that I gave you. Okay, and then you're going to get your final answer of 0.0052. Now that is equal to my x, okay, which is also equal to my H plus, if you remember from your original ice. So when I plug that into my equation of negative log of my H plus, this is once again at equilibrium, I get a pH of 2.3.